This is Algebra 1, Lesson 6.2, Solving Inequalities Using Multiplication and Division. This lesson starts on page 330 in your book. So we talked about in the last lesson the four properties of inequalities. We had the addition property of inequalities, which was if A is B, then A plus C is less than B plus C. Subtraction, sorry, my little pointer wasn't working. Subtraction property of inequalities, if A is less than B, then A minus C is less than B minus C. Multiplication property of inequalities, if A is less than B, then C times A is less than C times B. And if A is less than B, then negative C times A is greater than negative C times B. So you'll notice right here that we changed the directions of the signal right here, or the inequality. So here we had less than, and when we multiply by a negative number with inequalities, it's going to change the direction of the inequality. So the same thing, division property of inequalities, if A is less than B, then A divided by C is less than B divided by C. However, if A is less than B, then A over negative C is greater than B over negative C. And so once again, you can see that we switched the inequalities because we had a negative number that we have introduced into this. So that's important to remember that a negative number will change the direction of the inequality. So the inequality rule, when multiplying or dividing by a negative number, you must reverse the inequality symbol. Multiplying or dividing by a positive sign stays the same. So we're only talking about the negative number. So we'll kind of go over this a different way here. So if you multiply so we have an original inequality here, which is 1 over 2x is greater than 2. It says multiply each side by the same positive number. So we multiply both sides, by 2. So, if we multiply both by 2, we would end up with x is greater than 6 there. Now, on the next one here, on the division, it says divide each side by the same positive number. In our equation, originally inequality was 3x is less than or equal to 9. So we divide both sides by 3. And we end up with x is less than or greater than 3 over here. And so nothing changes because we didn't introduce a negative to it. Now, third one here is our inequality is negative x is less than 4. We're going to multiply each side by the same negative number and reverse the inequality sign. So we multiply by negative 1. I can't get the negative to work there. And a negative 1 on this side. And on this side, a negative 1 times negative x is going to give us a positive x, which shows up right there. And a negative 1 times 4 gives us a negative 4. But most importantly, our sign will switch. So we go from less than to greater than. On this, and the last one, it says divide each side by the same negative number and reverse the inequality symbol. So our original equation is negative 2x is less than or equal to 6. And so we divide both sides by negative 2. And we end up canceling out the 2's over here, this side. So we end up with x right here and then negative 2 into 6 is negative 3, and we have reversed our signals from less than to greater than or equal to. So here's another example. We have 4 is less than 6, so we multiply by a positive that doesn't change the inequality. So if I multiplied both sides by 2, I would end up with 8 is less than 12, and nothing changes about the inequality. If I divide by a positive, 4 is less than 6 divided by 2, I end up with 2 is less than 3, and nothing changes here in the inequality. So here we have another example. We have a over 4 is less than or equal to 10. That's our original inequality. We're going to multiply both sides by 4 to get rid of the 4 right here in the denominator. So we divide, multiply. My apologies. Multiply both sides by 4 to get rid of the denominator here. And we're using the multiplication property of inequality. So we know that our sign, because we're multiplying by a positive number, nothing changes with the inequality here. So we end up with a is less than or equal to 40, and then I can plot this by a is less, so I have an equal to in my inequality. So I have a closed circle there, and then my line is going to the left. Example 2, it says divide by a positive number. So I have 4x is greater than 20. That's my original inequality here. I want to separate the 4 from the x here. So I'm going to divide both sides by 4. So I end up with 4x over 4 is greater than 20 over 4. And so x, when I divide that out, I end up with x is greater than 5 when I simplify. I don't have an equal sign, so this line, this circle right here should be open and not closed. And this says x is greater than 5, and so it is everything to the right, all the real numbers to the right of 5. Okay, so now let's talk about multiplying and dividing some more. We have k over 4 is less than 1/2. That's the original inequality. We need to get the 4 away here, so we're going to multiply. So if you have a fraction or division here, you have to multiply to remove the denominator. So when we multiply both sides by 5, that cancels out the 4's, and then end up with k, and 1 over 2 times 4 is 2. And I'm left and I showed you how I multiplied that in case somebody along the lines doesn't know how to multiply 1/2 times 4. And I did not have an equals sign in my inequality, so it is an open sign, and k is less, so it is all real numbers going to the left. So in this one we have in checkpoint 2, we have 18 is less than or equal to 2k. That's my original inequality. I divide both sides by 2 to separate the 2 from the k here to get rid of it, and I end up with 18 divided by 2 is less than or equal to 2k over 2. And when I divide it out, I end up with 9 is less than or equal to k. That's when I simplify. And boy, is my handwriting with the stylus today bad. And then I had an equal sign, so I have a closed circle. 9 is less than k. And so we have a closed sign here, and 9 is less than or equal to k. And so k is all the real numbers going to the right.
I'll be fine right here. I just gotta wait for the world to stop spinning.
You should have let them keep an eye on you, Matt, like they wanted to.
Ah, years playing football. I know how to take a knock to the head. Thanks for the ride. I felt responsible to make sure you're okay. I'll be fine. But what a coward Brad is, sending his wife to do his dirty work. Why is so sure that he sent her? I told you I saw a car that night, right? Last night I saw Lily. Yeah.
The next checkpoint is 6 is less than t over 5. That's my original inequality. And I'm going to multiply both sides by 5 because I have to get rid of the 5 here in my denominator. And 5 times 6 is 30. The 5's cancel each other out here. I'm left with t. So 3 is less than t. And 30 is less than t. I don't have an equal sign in part of this, so it is an open circle going to the right because 30 is less than the values of t. Here, our next original inequality is negative 2 is less than 3y. We're going to divide by 3y to separate out the 3 and the y and to get rid of it. So we end up with negative 21 divided by 3 is less than 3y divided by 3. The 3's cancel each other out and just leave a y, and 21 divided by 3 is negative 7. And it says negative 7 is less than y, so it is an open circle. There's no equals. And y is all the real numbers to the right of negative 7. So for multiplication property of inequality, c less than 0, for all real numbers a, b, and for c that are less than 0, if a is greater than b, then AC is less than BC. If A is less than B, then AC is greater than BC. And in the division property of inequality, for all real numbers A, B, and C that are less than 0, if A is greater than B, then A divided by C is less than B divided by C. And if A is less than B, then A divided by C is greater than B divided by C. So just to make a note, this is when C is less than, I didn't do that very well, when C is less than 0, okay? So here we have, anytime you multiply or divide both signs of an inequality by a negative number, you have to reverse the sign. So negative 5x minus d is less than 26. When you multiply or divide, then you have to reverse the sign. So the less than becomes greater than, less than or equal to becomes greater than or equal to, greater than becomes less than, greater than or equal to becomes less than or equal to. So to multiply by a negative number, and let's say the original inequality is negative 1/2 y is less than or equal to 5, then we have to multiply by negative 2, and then we're going to reverse the inequality. So we multiply by negative 2, so we end up with negative 2 times negative 1/2 y is going to be greater than or equal to 5 minus negative 2. And you can see here that I reversed my signs. They're reversed all the way through. And our answer then is y is greater than or equal to negative 10. And so here, this instead of just a, so we have the right dot here, we have a closed dot. And the answers are for y are anything greater than or equal to negative 10 and going to the right. Okay, so in this example, we have, we're going to divide by a negative number. So our original inequality is negative 12m is greater than 18. And negative 12m divided by negative 12 here, and 18 over negative 12 here, we're dividing by 12, negative 12 to isolate the m. We end up with m is less than negative 1.5 or negative 1/2. And important to see that I started with greater than and I switched to less than, and our number is negative, m is less than negative 1.5, and so it's going all real, the solution is all real numbers going to the left of that. And in this example we have negative 8x is less than or equal to 20. That's our original equation, inequality. I'm going to divide both sides by 8 to isolate the x. I end up with negative 8x over negative 8. The 8's cancel each other out. That is less than or equal to 20 divided by negative 8. I end up with x is less than or equal to negative 2.5. And since x is less than 2.5, and we have an equal sign, we have a closed dot, and we are going to the left. We have another equation here. This is checkpoint 5. When we multiply or divide, our original equation, inequality, I keep saying equation today, is negative 1 over 5p, which is greater than 1. We end up with negative 5 times negative 1 over 5, because we're multiplying to get rid of a denominator. It's less than 1 times negative 5, and so 1 times negative 5 is just going to be negative 5, and negative 5 times negative 1 over 5, this leaves p, so we have p is less than negative 5. We have an open circle because we don't have an equal part to this inequality, and it is going to the left of negative 5. Here we have on checkpoint 6, we have negative 2, 3x is less than negative 5. That's the original inequality. We have negative, so we're going to multiply by the reciprocal here, which is negative, because we have a negative, so we're going to multiply by the reciprocal of this and then reverse the inequality. So we're going to do two things on this one. So we end up with negative 3 over 2 times negative 2, 3x is greater than, I've reversed my sign here, is negative 3 over 2 times negative 5. I end up with x is greater than 15 over 2, and x is, then I simplify that, and I have x is greater than 7.5. I divided 2 into 15 here, so if someone along the way doesn't know how to do that, it's there. And we don't have an equal sign, so and my number line didn't go to 6, 7, or 8. So we have an open dot going from 7.5 out. Checkpoint 7 is negative 1/4 times k is less than or equal to negative 4. That's my original inequality. I'm going to reverse the equal sign, and then I'm going to multiply both sides by negative 4. So I reverse my inequality, and I have negative 4 times negative 1/4k is less than or equal to negative 4 times negative 4. I end up with just k is greater than or less than 16, and that is my answer. I can have an open I can get my pen to work, I have a closed dot there, and everything is going to the right from 16. On checkpoint 8, it's 14z is greater than or equal to negative 70. I'm going to reverse and use the reciprocal. So, okay, I thought that looked funny. There is no reciprocal here. I mean, we're not going to use that term right now. We're going to reverse our sign, and we are going to multiply by negative 14. And we have, once I get my pointer, okay, so 14z is greater than or equal to negative 70. We divide both sides by 40. That is less than or equal to negative 70 divided by 14. And z is less than or equal to 5. I did the division here for that if you need it or someone in the future needs it. And we have a closed dot, and we start at 5, and all the solutions are going to be to the left of that. I meant to say up here, divide. Oh. Okay, divide. On checkpoint 9, we have negative 24 is less than or equal to 6t. We're going to divide by 6, and we are not going to reverse the sign because 6 is positive. So we divide by a positive 6, and we end up with negative 4 is less than or equal to t, and then we go negative t is here, closed dot, and all the solutions are going to be greater than negative 4. Okay, checkpoint 10 is 12 is greater than negative 5n. We are going to divide by negative 5, so we will reverse our sign from a greater than to less than. When we divide both sides by negative 5, we end up with negative 12 over 5 is less than n. And then we end up with, on this, I took my pointer away, hang on, negative 12 over 5, which in order just to know where to put that on the number chart, number line, you divide 12 by 5, and you get 2. It's a negative. It's going to be negative because we were working with negatives there. And so I now know that my point is negative 2.4. So that is an open dot, and it's going to be all the solutions, all the real numbers going to the left. This is the same thing you've all already saw. I just want you to really sort of get it in your head what these properties mean and what happens. So take a minute and read this to yourself out loud, so that, or whatever, so that you get it into your head. And again, Algebra 1, 6.2, your answer or your assignment is 333 to 335, and you're going to do exercises 19 through 22, 29 through 30, 28 through 40, 55 to 56, 58 through 61, and then on 62 through 90, you're going to do even. And I did give you, you have one word problem, and on the next slide I give you how to work that one out. So when we look at the sample for number 54, that problem, let me find it here. It's talking about posters. You want to buy some posters to decorate your dorm room. Posters are on sale for $5 each. Write and solve an inequality to determine how many posters you can buy and spend no more than $25. So what we do know, when I make a verbal or label everything, I have posters that are going to cost $5. You have a total of $25 in money, and you're trying to find out an unknown number of posters which will represent with P, and that would be 5P is less than or greater than 25. We divide the P part by 5, so we end up we're going to end up with P is less than or greater than 5 or less. You can buy 5 or less posters.